Hello guys, in this session we are going to see about multiplexer and demultiplexer. Multiplexer means transmitting a large number of information unit over a small number of channels or lines. A digital multiplexer is a combinational circuit that selects binary information from one of many input lines and directs into a single output line. A selection of particular input line is controlled by a set of selection lines. Normally, there are two n input lines and n selection lines. Those bits combination determine which input is selected. Combinational design procedure. The multiplexer shortened MUX or MPX is combinational logic circuit designed to switch one of the several input lines through a single common output line by the application of control signals. Multiplexer is a combinational circuit that selects binary information from one of many inputs line and directs into a single output line. The selection of particular input lines is controlled by a set of selection lines. Here is a truth table displayed. So y1, y2, y3, y4, y6, y7 are the inputs and ABC is output. In this inputs line are 2 power n and selections line will be n. So output lines are 3. Block diagram for multiplexer will be looking like this. There are 4 inputs line, that is D1, D2, D3 and D0, and 2 selection lines S1 and S0. So single output line. In case of demultiplexer, it will be vice versa. Function table. So selection lines are S1 and S0 and the inputs line are D0, D1 and D2, D3, and Y is single output. So we can see that it's a normal XOR operation are done here. Then circuit diagram for multiplexer will be looking like this, and 4 selection lines are selected, 2 from NOT gate, and there are 3 input lines. So each AND gate will receive the 3 inputs. So by these 2 AND gate outputs are combined to form input of OR gate. So finally we are getting final single output. Demultiplexer, vice versa of multiplexer. The function of demultiplexer is contrast to multiplexer function. It takes information from one line and distribute into given number of output lines. So output line will be 2 power n. For this reason, the demultiplexer is also known as a data distributor. Decoder can also be used as a multiplexer. In this 1:4 demultiplexer circuit, the data input line goes to all of the AND gate. The data selected lines enable only one gate at the time, and the data on data input line will pass through a selected gate to the associated data output line. Combinational design procedure. Demultiplexer is a combination circuit that performs a reverse operation of multiplexer. It is a single output, n selection lines, and a maximum 2 power of n will be outputs. Input line will be connected to one of these output based on the value of selection lines. Objective. Demultiplexer is a circuit that receives information from single line and directs 2 power of n possible output lines. The selection line's specific output is controlled by the bit combination of n selection lines, and normally shortened form it is used can be DMUX. And AB for inputs and C will be selection lines. So truth table will be looking like this. S1, S0 or inputs, IP also input, and D0, D1 and D2, D3 are outputs. In this IP is a selection lines. So 2 power n will be output, so input will be single input. So IP is a single output, and S1 and S0 are 2 selection lines. Based on the selection lines, the operation will be taken. Block diagram for demultiplexer. So we have seen that there will be a 2 power of n outputs. So S1, S0 with the selection lines. So 1:4, 1:4 demultiplexer, also called decoder. Function table. Here also we can see that they are using normal XNOR gate operations. So y is equal to x S1 dash S0 dash and plus X S1 dash and S0 plus X X1 and S0 dash X plus S1 and S0. So logical diagram for demultiplexer will be looking like this. Vice versa of multiplexer. So there will be 4 outputs raised by single output. Same as three inputs will be taken for AND gate and will be received from 2 selection lights and 1 input. Next, flip flops. The flip flop is a sequential device that simply its input signal and changes it to output state only at the time of determined by the clocking signals. Flip-flop may vary in the number of inputs, those and manner in which the input is affected by the binary states. Types of flip-flop: SR flip-flop, D flip-flop, and JK and T flip-flop. First, we are going to see about SR flip-flops. So the clock RS flip-flop consists of NAND gates and output changes. It states with respect to input of application clock pulse when the clock pulse is high and the S and R input reach the second level. The NAND gate in their complement form. The flip-flop is reset when R is input is high and S input is low. Flip-flop is set when S input is high and R input is low. When both inputs are high, the output is an independent state, that means invalid state. So characteristics table of SR flip-flop will be looking like this. Clock pulse will be displayed here and inputs are S and R. Present state Q and next state Q plus 1. Likewise, there will be 8 outcomes. Next, D flip-flop. To eliminate the undesirable condition of indeterminate state in the SR, the flip-flop when both inputs are high at the same time. The D flip-flop, the input never made equal at the same time. This is obtained by making two inputs complement of each other. So to overcome the disadvantages of a SR flip-flop, D flip-flop is made. And the pentagram of D flip-flop will be looking like this, and a normal block diagram. So IC used in this flip-flop will majorly be IC 7474, and the characteristics table, clock pulse, and input will be D and output will be Q. Next, JK flip-flop. The indeterminate state in the SR flip-flop is defined in the JK flip-flop. JK input behaves like S and R input to set and reset the flip-flop. The output Q is added and with K input the clock pulse. Similarly, output Q is AND with J input the clock pulse. When the clock pulse is 0, both AND gate are disabled, and Q dash output retains the previous value. When the clock pulse is high, J and K inputs reach the NOR gate, and when both inputs are high, output toggles continuously. This is called race around condition. This must avoid. So characteristic table of JK flip-flop will be looking like this, and output and inputs and clock pulse are displayed here. Next, T flip-flop. T flip-flop is a much simpler version of JK flip-flop. The state of flip-flop is changed by the momentary change in this input signal. Momentary change is known as a trigger, and the transition is set to triggering the flip-flop. The pulse trigger clock flip-flops. Pulse start from the initial value of 0 and goes momentarily to 1, and after short while returns to its initial value 0. The clock pulse is either positive or negative. Positive clock source remains at 1, and during the interval between the pulse goes to 1, and during the occurrence of pulse goes through two signal transition from 0 to 1 and returns 1 to 0. So block diagram will be displayed here. Toggled pin and inputs, inverter input and clock pulse. Normally in this T flip-flop will be used complement function, so we are using the AND gate. So characteristic table of T flip-flop will be displayed here, and T column will be used for inputs, and Q and Q dash are outputs. So Q and Q dash will be complement for each other. Next, shift resistor. Shift register is another type of sequential logic circuit that is used for storage or transfer of data in the form of binary numbers and then shifts the data out once every clock cycle. Hence the name shift register. It basically consists of several single bit D-type data latches. One of each bit 0 or 1 connected together in a series or daisy chain arrangement so that the output from one data latches become input of next data latches and so on. The data bit may be feed in or out of the register seriously. That is one after the other form, either the left or the right direction or in parallel. That is all together. The number of individual data latches required to make up a single shift register is determined by the number of bits to be stored with the most common bit, 8 bits. That means 1 byte. Shift registers ICs are generally provided with a clear or reset connection so that they can be set or reset as required. So first we are going to see about serial and parallel out shift register. The shift register which allows a serial input and proceed parallel output is known as serial in parallel output shift register. This circuit consists of 3 D flip-flops which are cascade. That means output of one flip-flop will be counted as the input of next D flip-flop. All these flip-flops are synchronized with each other since the same clock signals applied to each one. In this shift register, we can send a bit serially from input of leftmost D flip-flop. Hence, the input is also called serial input. Every positive edge triggering of clock signal, the data shifts from one stage to next stage. In this case, we can access the output of each D flip-flop in parallel, so we can get parallel outputs. So this is called serial in and parallel output shift register. Block diagram of this serial in parallel out will be looking like this. IC used is 7474. So NAND gate. Next, truth table. You can see that outputs are QA, QB, Q and QC and QD. So outputs are taken from parallelly and inputs are sent serially. Next, parallel in and parallel out shift register. So this is code to synthesize the operator in Vsdl. We can notice that normal code for Vsdl and our data flow will be sum is equal to lesser than or equal to a XOR b and k is equal to greater than or equal to a and b. Next, behavior modeling. This is also code to synthesize the operator. Next, these are the main syntax that we are used here: ndef and nprocess and nbehave. So these codes are case sensitive. It must be written properly and without any symbols changed. Structural modeling. So codes. This is also code. And thank you for watching this video.